the last one was tricky.
Yeah, last one.
I find it somewhat tricky.
Okay. Right, so what's the first one?
It's simple, that is the same.
At approximately 100 gram apple falls with an acceleration of approximately 10 meters per second onto a sleeping
Physicist.
physicist.
Yes.
How much force is the apple experiencing while it's falling?
Great.
I mean,
That will create a lot of
a lot of physics.
a lot of physics
All
due
of
to
it.
apple.
This is what I did.
Yeah, so, F, la, that means no. Yes. Yeah. F equals MA. What's the M? 0.1. We'll take down as positive. 0.1 and the A is 10. Actually, we know it's not really 10. What is it?
9.8.
Yeah. So this would equal 1
Newton.
Newton.
Yeah.
Is my joke. You get my joke? The answer is 1 Newton. Thank you. So the students last year, they're like, what? You didn't get it? Really?
What is yours?
Newton.
Newton.
1 Newton.
1 Newton.
With one apple,
Yeah.
he created a lot of physics.
Oh, it doesn't matter. It doesn't matter.
Never mind.
Never mind, yeah. Okay. Some people got it anyways. Right.
A 2.5 kilogram ball is dropped from 49 meters. How much force is being applied to the ball as it falls, and what do you think is applying this force?
No, that's 2.5 kilograms, yeah?
Yes.
Yeah.
Dropped from 49 meters.
Yeah.
Now, not that I was trying to trick you, but I kind of was a little bit. The 49 meters is not important for the question. It doesn't matter.
Yeah.
By A.
Yeah, it's because it's just F equals M by A.
I ignored this, but then I was like, do I?
No, and now the reason I did that is because sometimes, not always, very rarely, but sometimes in the exam, this happens where there's an extra piece of information and you're left wondering how come I didn't use it. And it does happen
I was
sometimes.
thinking the same, but I thought, all of the questions you gave in homework are tricky. I was saying that there must be something.
No, there wasn't. It was just simple F equals MA. So did you get this answer? 122.5.
No.
No, sorry.
4.5.
Oh,
Yeah.
sorry, stupid, sorry. 9.8.
4.5.
2.5 times 9.8. 1. What did you get? 24.53 about.
Yeah.
So it's same. I first applied S equals to UT plus half ST squared, GT squared.
Unnecessary,
Yeah,
totally
and then
unnecessary.
unnecessary.
Yeah. Okay, tree. What's tree?
Yeah, it's true.
A car is being tested
Yeah.
for safety.
Yeah.
The 2000 kilogram is driven by a test dummy.
Okay, yeah.
Into a wall, the car hits the wall at 20 meter per second,
Yes.
minus 1.
Yes.
The front of the car, which is 1.1 meter long,
Oh, this is an ugly car. Right, 1.1 meter, yeah.
begins to crumble, and then finally the car is brought to
Yes.
rest. How much force is the wall applying to the car while it's decelerating?
Okay, good. So this one, last year, this caused a lot of confusion with students. So just listen carefully. I want to make sure you Hey, Turkey, come on, listen carefully. I want to make sure you understand what's happening. Now, I'm sure you've seen these videos before, and I'll try and find one now for you if I can. I was able to find one last year. So you have the car being tested, and the car is driving along at a constant speed, and then it hits the wall, and then comes to rest. Of course. So, it has a speed, and then here it comes to rest. So, is it accelerating?
No.
Decelerating.
Well, decelerating. Well, it's constant
Here,
here, but when it hits the wall and comes to rest,
Yeah.
it's definitely not constant.
Yeah.
Yeah. So, hang on. Test car crash test dummy. No, what do I want? Car crash test, something like this. If I can get you a video here. Yeah, perfect. Terrifying, perfect. That's what we want. And this idea will come up again in another question, so if I just... Yeah. Okay, yeah. So, now, let's just go back. No, stop. Slower.
I think it will start.
Okay, there. So the car's going at constant speed here, and now it's not. So there must be some force here because its speed is changing. Now this, so you can see here, it's a constant speed, but now it's not. It's changed. Yes, here we go, more crashes, fantastic, yeah. Now, okay. So, if you were to look at this in slow motion, what's happening is the car is slowing down when it's in contact with the wall.
Yeah.
So it's almost like the wall is pushing on the car with a force to slow it down. But it's only happening while it's in contact. It's not happening before it hits the wall and not after the wall. It's only while it's in contact with the wall. During the contact part. Yeah, no, this is good. So here, there's no force being applied to the car. But the moment the car touches the wall, there's a force from the wall which is slowing the car down. There, perfect. This crumpled part, this crumpled stage, is when the force is being applied. But as soon as the car has crumpled and come to rest, then there's no more force from the wall. So here, that was the end. Now there's no more force.
Yeah.
Okay, I don't think there's anything else. This looks like another crash. No, this is safe driving. Yeah, okay. Wait, here, one more. So no force. No, it's during this stage where there's the force. And then at rest, yeah, that's it.
So the force from the car and from the wall.
There's a force from the car and from the wall, yeah. But I don't know if for these tests that the engine is off and they just shoot the car at the wall. I don't know. So we'll have a look at the question now. But do you understand that the force is only active during the contact with the wall? So what do I ask for here? Is it the force from the wall?
How much force is the wall?
Yeah. So let's try and figure out the information here. The U is 20. The V is 0. The A we don't know. Will it be positive or negative?
Negative because it's going.
The T we don't know. And the S 1.1. Because the car has a crumple area of 1.1. So the force is being applied for 1.1 meter. That's the crumple area. Sorry, Andy, do you know this word crumple?
No.
If you have,
maybe
Yeah.
accident or something like that.
here, I'll show you, Andy. It's a verb. So this means to crumple. Yeah, it's like squash. Yeah. So the crumple distance is 1.1, and we call this in engineering the crumple zone.
What's the spelling?
I haven't a clue. See, crumple.
C-R-U-M.
I feel like it should be at least C or U. Crumble.
Yeah.
No. Crumple. That's crumble. Crumple.
Crumble, no,
I think it's crumble like this.
But this is a type of food, like apple crumble. I don't know if there's a P instead of an M. If it's crumple,
Crumble.
is it M or P?
No. Crumble is a food.
Crumble is a food. That's what I thought. Yeah. Is it with a P? Crumple. Yeah.
1.1, is it given?
Yes. Yes, it is. Yeah. Is it with a P?
Crumple.
C-R-U-P-L-E?
Yes.
Yeah, this is, oh.
Yeah.
Yeah, this
Crash
one.
or to crash into it.
Yeah. Okay. Great. So crumple zone is
What is that?
C-R-U-M-P-L-E.
Oh, sorry, CRUMPLE, crumple zone. Okay. This is the part of the car that gets crumpled from the crash. Okay. Right, so what should I calculate here? The A. How can I get the A?
We will get S is equals to U plus V upon 2 P
S equals, U plus V over 2
T.
T. Oh, and we know the S. S equals U plus V over 2
It's 0.11.
Yeah.
T. And what did you get for T?
0.11.
1 second. Oh wait, but I don't need the T. Sorry, I needed the A. Doesn't matter.
So it's
I can just
A
do
equals
V
to-
equals U plus AT.
We can simply do A equals to V upon T.
Yeah, because the V is 0. 0 equals 20 plus 0.11 A. So A equals,
181.81.
Yeah.
is that all? I was expecting bigger. 182, I will say.
Yeah.
182. But that's the A, which is quite big. But we don't want the A,
We want F. Now
we want the F. So the F equals
minus
MA. And what was the M? 1200?
2000.
Oh, 2000.
Oh, it's so big.
363.
Now we're talking.
620. Yeah.
363636. Or if
No,
you
wait,
want.
363620.
No, but this is my rounding. Don't worry. I'm going to fix it anyways. I'm going to make it 364000.
No, but there is no decimal point.
I don't have a decimal point.
Is there?
No, there's none here. Yeah.
Wait.
Because we have done 181.8, so it's like
81.
Okay, doesn't matter. 364. It's close. Did you get 364?
we got 363620.
So it rounds to 364. That's all I care about. What's wrong with you?
I have no decimal point. How can we round up?
No, but I'm rounding it to 3 significant figures. There's no. You've done this with Lorraine. How many significant figures?
Yeah.
Yeah. So like 2,206. You can round that to 2200.
Yeah.
That's 2 significant figures.
Oh, okay.
So I'm rounding it to 3 significant figures.
That's fine.
Yeah.
We are
So 364 kilo newtons. 364,000 newtons.
But it won't be in minus? Yeah.
At minus, of course, yeah.
Is by kilo.
No, you don't have to. I just like to. 364 kilo newtons. And that's a lot. Kilo newtons, you know.
At first I thought it's the wrong answer, but I just...
Because it was too big?
Yeah.
No, it's big,
Okay,
it's
so why
big.
is it kilo newton?
Oh, because I just,
4,000.
yeah,
It's now 364 multiplied by 1,000.
Yeah.
Okay, so I'm right.
yeah. Okay, that's okay, is it? Alright, how many are there? Is there another one?
2 more.
2 more. Which one's this now?
4.
4, okay.
80 kilogram space walk is traveling at 2 kilometers per second. It then engaged.
Thrusters. Was it rockets? Yeah.
Then it engaged and it's propulsion
Propel?
Propulsion.
Or propulsion, yeah.
system.
Yes.
And accelerates for 3 seconds.
Ah,
The propulsion
yes.
system is capable of delivering 1 kilonewton of thrust. How
Ah.
fast is the boat going after
Okay, so in this one, I give you the force. I said it's 1 kilonewton, which is 1,000 newtons.
4 or 5?
This is
Four.
4, yeah. So F equals MA. So A equals F over M, which equals 1,000 over 80, which equals, what's that, 100 over 8, which is 50 over 4, which is 12.5?
Yeah.
12.5 meters per second squared. What's the U? U? 2?
2,000.
The U is 2. Oh wait, is it 2 meters or kilometers?
It's 2 kilometers.
Ah, 2
So we'll write
kilometers,
2,000.
so 2,000.
Yeah, meter.
And this is the A. This is the A. And we know the T. What's the T?
3.
3. And what do I want? The V, is it?
Yeah.
Ah, well that's just V equals U plus A T.
27.5.
Yeah, so 2,037.5 meters per second, or if you prefer, that is 2.0 0.04 kilometers per second if you convert it back and round it off. Although it's fine to leave it like this.
2037, yes, I've got the same.
Yeah, well, you sound surprised. Yeah. Okay, was that it for 4?
Yeah.
Yeah, and you said 5 was tricky.
Yes.
Yeah, okay, what about 5 then? What happens in
A
it?
75 kilogram man jumps from a height of 2 meters on some grassy lawn.
Ah, this one. Okay, let me just draw that. Can I scroll down a little bit here?
Yeah.
Okay, so hang on. We have our man, and he is 75 kilograms, yeah?
He jumps on grassy.
He jumps on some grass. What else do we know? Do we know? 10 meters, okay. How much? 2 meters. Okay. Yeah. Next. What?
The man bends his knees when he lands and therefore deaccelerates over a distance of 20 centimeters.
There
How
he
much
is.
force how much force in total does his body feel while he's deacceleration?
Now, is it 20 milliseconds, the time?
The time there is.
There is no time.
You said he bends his knees.
For it's 20 centimeters.
Oh, the distance is 20 centimeters. I'm sorry, okay.
0.2.
Now, this one is just like the car crash, because what's happening here, if I just kind of draw it here in zoomed in, this is his foot, if we zoom in, okay? There's a downward force. What's the downward force? His weight, yeah? And he's accelerating as he's falling to the ground. But then what happens when his foot hits the ground? It's like a crumple zone. His legs are bending. So the ground will be pushing up on his foot with some force, and of course he still has his weight going down. But which will be bigger? The force from the ground, because it's slowing him down. He doesn't continue to fall. And then eventually, after some time, a short time, what will happen? The F will then equal the W. So as he's falling and lands on the ground, in slow motion, what's happening is his legs are bending, there's an up force from the ground, and this is slowing his speed until he's at rest. Okay? So the ground is giving him a force in his legs, opposite to his weight. And this is the force that breaks your bones if you don't bend your knees, if you fall from too high. Yeah. And it's our job to calculate what this force is. So the first thing we should do is work out how fast he's hitting the ground. So this is just a simple UVATS problem. So the U is 0, the V is we don't know, the A is minus 9.81, the T we don't know, and the S is minus 2. He falls from 2 meters high. Yes? Yeah. So what will give us the V here? V squared? V squared equals U squared plus 2AS. And there's another 2. Yeah. 2. Yeah, all the minuses cancelled, so. Now, V has technically 2 answers, plus or minus 6.26 because of the square root. Which answer do we take, of course? Oh, the negative, because he's fallen down, yeah. The 6.26. Okay, is that okay?
Yes.
Now let's go back to our zoomed in foot. Or let me redraw it. So here's the graph. Here is his foot. And here is his leg. So when his foot hits the ground, it's
Is his head?
no, this is his foot. And then when his foot hits the ground, his leg bends. That's a bend. So it's like a crumple zone. Yeah, it broke here. Yeah. I don't really know how to draw it. Well, you get the idea. He's standing, but then in slow motion, he's spending. So he goes from having minus 6.26 to having, that's going to be his U in this picture, and then what's his V?
0.
It's going to be 0 in this picture. So he'll have an acceleration, but this time it will be positive, going up. So what else do we know? We know the S, the small distance this crumpling happens, is 0.2. I suppose it's a minus because it's happening going down. We'll fix the signs anyways. So if I want the A, which formula could I use here? V squared again? V squared equals U squared, the minus gets squared away, plus 2AS, and the minus is cancelled. 2 AS. And there's a minus here, sorry. Okay, so the A will be a positive, good. The A, oh my goodness, that's really big. Let's double check it. Did you get a big number? Yeah. Okay, 97.97 meters per second squared. So that's a huge upward acceleration from the ground. Is that what I wanted, or did I wanted the force? So, F equals ma. What's his mass, please? 75 kg, wasn't it? Yeah. So, the upward force is 7,348 newtons, or if you want, that's 7.35 kilonewtons. Yeah, now that's probably getting close to the limit that your leg bone can handle. I feel like, I can't remember where I read this, but I'm pretty sure 10 kilonewtons will break your leg bone. 10 kilonewtons. I'm pretty sure 10 kilonewtons is what will break your leg bone. So you can see that he's getting close to breaking his leg bone. Okay, is there a next part to this?
Yeah, if he only bends his knees by 10 centimeters, then how much force is it?
Yeah. Now watch this. I'm not going to redo the whole question. I'm just going to change that piece of information. So instead of having 0.20s, I should have 0.10. The first time I used 0.20 was here.
Yeah.
So if I just change that to 0.10, I get the answer for the second situation. And in fact, changing that to 0.10 will have the effect of making this twice as big. So the answer will be 14.70 kilonewtons.
So
It'll be broken down. But can you see, the point I wanted to make with this question is, it makes a big difference if you can bend your legs for longer when you impact the ground. So 10 centimeters would be, you bend your legs this much, about, and 20 centimeters would be twice the distance. And this, you can see, makes a very big difference. And you see this when you look at cats that land on the ground, or people who land on the ground in slow motion. You try to bend your legs for as long as possible to give you the reduced force on impact. Okay. I don't think, is there another part to this?
Yeah.
Oh, there is.
assume that the human leg can withstand 9 kilos.
Oh, 9 kilonewtons. So then the question is going to be, how long do you need to bend your leg for, isn't it?
Assume he bends his knees as much as possible,
Yeah.
50 centimeters.
What's the maximum height you can jump from without breaking his legs then?
Yeah.
Okay, alright.
From the bed.
Let's have a look. What's wrong? What do you think? Yes. Okay. Now, so the maximum he can handle is 9 kilonewtons, okay? And the distance is still going to be the 20 centimeters. So the question is, what's the maximum height you can jump from? So we need to work backwards, okay? So we'll start off with the F, what is it? 9 kilonewtons. So that means the MA is 9,000. So we know the M, don't we? It's 75. So that means the A is maximum is 120. Yeah. But we still know what the U is. What is it? Oh, sorry, no, sorry. We know the A is 120, and when he hits the ground, the V is 0, and the S is still 0.2. So we can work out what the U is when he hits the ground.
That is 0.2.
That's the maximum he can bend his legs.
No, it says, and assuming he bends his knees as much as possible.
Yeah.
Between two brackets, 50.
Oh, I'm sorry, I didn't realise I gave you that. So 50 centimetres is the most he can bend his leg. So then we can work out what the U is here when he hits the ground, the U for that part. What formula will we use? S equals, I want the U. V equals U plus 18. V squared, is it? V squared, I think.
Yeah, 2A.
V squared equals U squared, and that S is actually a minus 2AS. The 2 and the 0.5 cancel, so it's just going to be an A, is it? And the A is 120. So then U is square root 120. So that's 10.95. And then if we look at the second half, when he goes from the wall to the ground, what's the U? 0, and what's the V? Minus 10.95. Can you understand we're going backwards? So we first did his bending of the legs, and now we go back to him jumping from the wall. So the U for when he bent his legs is the V for when he jumped from the wall. So the U is 0, the V is minus 10.95, the A is minus 9.81, and it's the S that we want, the height of the wall. What formula here? S equals,
Same one?
Do you have E?
No, we
U
don't.
squared.
V squared,
Equals to U squared.
Yeah. V squared equals U squared, which is 0, and then 2A S. And the S, and there's a minus, and the S is negative because he's fallen down. So we get the S equals minus 6.11 meters. So the maximum height H of the wall is 6.11 meters. Now that really is the maximum. He has to bend his legs for 50 centimeters, which is quite difficult to do. Yes? All good? Yeah. Okay. Right, we'll continue then. If we don't get the lesson finished, we'll just break it up into two halves. Oh, that's the end of the question, isn't it?
Yes.
Yeah. Okay.